In this video, we are going to talk about section 9.5, and that is hypothesis test for one population mean when sigma is unknown. So in the previous section, section 9.4, we talked about how to do a hypothesis test for one population mean when sigma is known, right? But really the more realistic case is where sigma is unknown. We will see that similar to the situation in section 8.3, when we talked about confidence intervals, that when sigma is unknown, we will use the sample standard deviation S, right, instead of sigma. But then the distribution is a t distribution, okay? And so the procedure is going to be pretty similar to section 9.4, but there's a few places here and there where we're going to have to do things slightly differently. Okay, so let's go over the procedure. You're going to see a lot of it is similar, right, to the case where we're talking about the case where sigma is known. That is those problems from section 9.4. All right, so this is the procedure for the one mean t test. The purpose, right, is to perform a hypothesis test for a population mean mu. Our assumptions, right, are the assumptions that have to be valid in order for this test to be applicable are that we have to have a simple random sample. It has to come from a normal population or have a large sample. And then here is a key difference, right? Sigma is unknown. So we do not know what the population standard deviation is. All of the things that we talked about for the null and alternative hypotheses are the same as before. Okay. And same thing for the significance level. That'll usually be given to you. All right. And so then once you decide on or have determined the significance level, then what you would do is compute the test statistics. So notice here it's t, right, instead of z. It's t because when sigma is unknown, then this follows a t distribution, not a normal distribution. All right, and then another key difference here is that here we are using the sample standard deviation instead of the population standard deviation. We don't know what the population standard deviation is, but we can get these sample standard deviation from the sample that we've taken. All right. All right. So you can see that the steps are pretty much the same. There's just a few slight differences. All right. Next up is that we are going to find the p-value. All right. And there's a slight typo in here, so I'm just going to fix that on the fly very quickly. The typo here is we're going to use table 4, right, to obtain the p-value. So we cannot use table 2 because that only applies to the normal case or the case where we know the population standard deviation. We do not know that here, so we are going to have to use this table 4, right? And table 4 functions slightly differently than table 2. These values are going to give you the values for areas to the right. Are they going to give you the T alpha here? And then alpha is not the significance level, but it's the area to the right of these values, whatever T sub alpha value it is. So those values are listed up here across the top for certain select values. Here is 0.1, 0.05, 0.025, 0.01, and 0.005. Okay. So we will not, using table 4, we will not be able to get a p-value to 4 decimal places like we were doing in the previous section. We'll only be able to say that our p-value is in the range between these values given up here at the very top. But that's good enough for what we're doing. We don't need to get the exact p-value. Just a range will be good enough, because then we would just compare that to the level of significance and either reject the null hypothesis or do not reject the null hypothesis. Okay. The reason why there's not just one table, right, with the Z table, right, there's no degrees of freedom. It's just one standard normal distribution. So you can give the values down to a more precise level. Remember, when you're dealing with this T distribution, well, you've got the degrees of freedom as well. So, you need a chart, right, for every one of these values of degrees of freedom. Well, that's a lot of, pages. You'd need, 49 pages, right, or times 2, I guess, to represent that. And we don't have that. So we're just going to go with this table here, and I will show you how to do that. If we are running a two-tailed test, then our p-value, right, is going to be the same as before. Whatever our calculated test statistic is, we're going to take the positive version of it and the negative version of it, and then the p-value will be the area, right, that's to the right of it. Okay. To the right of the positive value, to the left of the negative value, rather. For the left-tailed test, it's going to be the area underneath the t-distribution to the left, right, of the value. And for the right-tailed test, it's going to be the area to the right over here. Okay. And so that part of it is pretty much exactly the same. What's going to be different is using the this table to look it up. It's done in a slightly different manner. So as we go through the examples, you'll see exactly how to do that. All right, step 5 is to compare the p-value to the level of significance. And if the p-value is less than or equal to the level of significance, we're going to reject, just like we did last time. If the p-value is greater than the level of significance, we do not reject the null hypothesis. All right, and then we are going to interpret the results of the hypothesis test. We're going to do that in the same manner that we did that in the previous section when the population standard deviation was known. Our conclusions are going to be these statements here verbatim, right? If we reject the null hypothesis, we are going to conclude that the data do not provide sufficient evidence. And then remember, it's going to support the alternative hypothesis. So that part of it will be pretty much identical. The alternative hypothesis part will be stated in terms of the specific alternative hypothesis. So just remember that the important part is that it has to be the alternative hypothesis. So it's either going to be that the mean is greater than, the mean is less than, or the mean differs from some value. If we do not reject the null hypothesis, our statement's going to be that the data do not provide sufficient evidence to support the alternative hypothesis. And again, this part with the alternative hypothesis will be stated in terms of the specific alternative hypothesis that you are testing. So it is a lot like what we did before. If you haven't watched that video, you need to go back and watch section 9.4 video and work those examples to get a feel for how these problems go. Okay, now we're going to work problem 9.108 from our book. It says the sample mean, sample size, and sample standard deviation are provided. Use the one mean t-test to perform the required hypothesis test at the 5% significance level. Okay. So our sample mean, x bar, is 21. Our sample size is 32. Our sample standard deviation is 4. And our null hypothesis is the population mean mu equals 22. Our alternative hypothesis is that the population mean mu is less than 22. Okay. All right, so we're going to run through the steps for the one mean t-test. Right here, we do not know what the population standard deviation is, but we do know the sample standard deviation. So the first step in the procedure for the one mean t-test is to determine the null and all alternative hypothesis. Those were given to us in this problem. Next up, right, is to decide on the significance level. They just give us the significance level in the statement of the problem as is the usual, right? We're testing at the 5% significance level. So alpha would be 0.05. Okay, next up is to compute the value of the test statistic. All right, it's x bar minus mu naught over s divided by square root n. In our case, right, x bar, the sample mean is 21. Mu naught is this number that's here in the alternative and null hypothesis, which is 22 in this problem. Our sample standard deviation is 4. And our sample size is 32. Okay, so we'll need to compute that out. And actually, I've already got that down over here. Right, so that comes out to be minus 1.41. Okay. When we're using table 4 to look up these p-values, we will also need to calculate the degrees of freedom. Remember, that is the sample size minus 1. So the sample size in this problem is 32. So the degrees of freedom is 31. All right, so you'll need to know that. We are also doing a left-tailed test here, right? And so what we will need, right, to look up is the area underneath the t curve, right, that's to the left of minus 1.41. Okay. So when we go to table 4, though, and look at it, right, if you look up here at the top, table 4, right, is giving you the area to the right of certain values. Okay. So we will have to adjust what we are looking up here. All right, so you can see it's a little opposite, right, of the table 2 lookup. It's different, so you're going to have to get used to how this works, okay? All right, so what we're going to do, right, first thing to know is that this t distribution, this t curve, just like the normal curve, is symmetric about the mean, right, which is 0 here, okay? And so what we're going to do is in the table look up positive 1.41, right? And we're going to find this area over here because that's what table 4 is, that's how table 4 is going to give that to us, okay? Over here, and then that value, the area to the right of 1.41, is going to be exactly the same as the area to the left of minus 1.41. Okay, so that's what we're going to do. So we would go into the table and look at the row, right, for 31 degrees of freedom right here. All right, and so we're looking for where 1.41 would lie. You notice 1.41 is not exactly in this row, right? But it is in between this number 1.309 and 1.696, okay? So that's not going to let us calculate the p-value exactly, right? But we know that it's going to be, our p-value is going to be in between these two numbers right here. It's going to be in between 0.05 and 0.10. So going back over here, right, we would know that our p-value, P, right, is going to be less than 0.1 and greater than 0.05, okay? So again, right, I looked up this number in the table, 1.41 on the row for 31. It was in between these two numbers right here, okay? And so then I go up and I look, that means our p-value is in between 0.05, right, and 0.1. So that's what we have, okay? All right, so again, this is different in that I am not going to be able to calculate my p-value exactly, right, using the table 4. But that's good enough, right, because the next thing that we're going to do is compare our value of p, right, and the value for alpha. So the value for alpha, right, is 0.05, right? And we know that our p-value is bigger than 0.05 and less than 0.01. So that is enough to conclusively say, right, that our p-value has to be bigger than alpha, the level of significance, okay? So in that case, what we do is we do not reject. The null hypothesis. That's the conclusion here. Okay. And let's see, what else did they want? All right, so they want the conclusion. Our last step, right, is to interpret the results, right? And so our results, right, say that the data do not provide sufficient evidence to support the alternative hypothesis, right, that the mean is less than 22. Okay, so again, where am I getting this conclusion from, right? That comes exactly from this thing right here. Okay, we conclude that the data do not provide sufficient evidence to support, and then whatever the alternative hypothesis is. So when you interpret the results, it's going to be one of these two sentences, right, with the alternative hypothesis being customized to whatever the alternative hypothesis is in the problem, right? In this case, it's u less than 22. But if the problem has some real world context to it, the answers on the tests and the last test and the final will be phrased, in English, but it will be just an English restatement of this alternative hypothesis. All right, so make sure you understand that important point. All right, so that's it for this one. The rest of the examples we will separate out into their own videos.